Hello everyone and welcome back. What you're going to see right now is a very simple example that is going to show us how the insert at the beginning and at the end, each one of those nodes that we see in here, this is what represents a node. So we have the data, we have next pointer, and we have a previous pointer. We already have a very simple doubly linked list in here. So it goes, this is the head, so this is the start, next points towards 15, so 10, 15, next 20, next 25, then nothing, next points towards none. For the previous of 25, it points to the one right before it, which is 20, previous 15, previous 10, and this previous is pointing towards none. Now, when I want to add or insert a new item, let's start with inserting at the beginning. It's in reality, what's going to happen is 3 steps. So what I want to do is say by the way, if I just say head point toward the new node, that's going to delete everything and just points here. That's a mistake. If I say new node point towards head, that can also create a problem. The best thing to do in here is say head dot previous equals new node. So I'm going to start with the first selection that I have, and I'm going to do a connector like this. So previous, look, head dot previous equals my new node. So I have the selection, but right now we are still starting at the head, and this node is still pointing towards nothing. Previous equals none, next equals none. So what I'm going to do now is make the next point towards head, and that is done by doing new node dot next equals self dot head. So self dot head is pointing here, my next is here. So right now I have this previous pointing backwards and this next pointing forward. Since I want this to become the first node in my linked list, the previous is going to stay as none because the first node always have none as its value. All I have now to do is delete this or change it, and I can say self.head equals new node. And now it's going to come here, jump to the next, then previous, and previous. So that is how you insert at the start or at the beginning of a doubly linked list. It's very, very simple. To reiterate, we are going to look at where the head is pointing and say the previous to it equals the new node, then the next of the new node equals the head, then the head equals the new node itself. Now, what about adding at the end of a linked list? It's actually the same, but we have to do a traverse in here. So if I was to, let's say, delete those quickly, and this is still my linked list, so 10, 15, 20, 25, and I want to add 30 at the end. What I want to do is first traverse from the beginning all the way to the end until next is equal to none, okay? And that is going to be a simple traverse where we're going to do a while loop. And then all we need to do is just a very simple connector in here where you can say start here, traverse all the way to the end. Right now this is current and this is new node. So current dot next, which is right now none, current dot next equals new node. And new node dot previous equals current. And that's it. It's done. I don't need to change next because right now next equals none, and I want that to stay as none because it is the last node in my linked list. So as you can see in here, it's actually fairly simple to insert and delete, and in the next lecture we're going to see how to do that using Python. Thank you so much, and I'll see you soon.